Okay, so we are officially recording. So welcome everyone. This is the AI research discussion for the AI and deep learning enthusiasts. Today's topic is going to be nationality classification using name embeddings. We have provided a link to the PDF of this specific research paper as well as the API. This research discussion was actually first proposed by one of our regular attendees, and so we have tried to broaden this topic so that others can also propose research discussions in the future if there's a specific topic that they would be interested in covering. General attendee guidelines we would like for everyone that's participating is first try to read the paper and find a few good questions or insights that you would like to share with the group. Try to be on time. Obviously, latecomers can be disruptive for online discussions, but anyone that does join, of course, we'll try to accommodate them and get them caught up. Please use a headset and try to be in a quiet location if possible and have a good internet connection. Obviously, we're muting everyone to start with. At any point, if you want to contribute to the conversation, please just unmute yourself. If you do have a lot of background noise, just keep yourself muted in the meantime. If you do want to do screen sharing, you are highly encouraged and welcome to do that. So try to have the research paper on your screen or other reference resources or materials that you have found helpful in deciphering the information available so that you can actually point to it when discussing that aspect of the paper. And then, yeah, there's no silly questions. So a lot of us are beginners, including myself. I'm not an expert in artificial intelligence, so please do not feel ashamed about asking anything. We really think that, asking questions is the best way to learn, and, especially in a collaborative session such as this, to learn from others. And as the AI and deep learning enthusiast group, we have strict guidelines regarding discrimination based on gender, ethnicity, sexual orientation, class, and prior experience or educational background. So we do want to highly enforce that anyone who violates those guidelines will be removed from the group immediately and will not be allowed to participate in future sessions. So obviously we do ask for a donation to reserve your spot, but we do still open the group and the sessions to people whether they donate or not. But we would like to encourage you to donate just so we can continue hosting these sessions for everyone and make them ongoing. And we highly encourage you as well to participate as a leader in the group. We think that it's important if there's a topic or a project that you really have in mind and you would like to get a group together to discuss it or to work on it, that you use this group as an opportunity for cross-collaboration. We have over 3,000 members, and so we would really love to see and foster more collaboration in the community. With that being said, I will go ahead and share my screen so that you guys can see my PowerPoint. And while I'm going through the PowerPoint in my own notes, again, I really want this to be a more interactive discussion. So at any point, I will likely just stop and ask you questions. And at any point, if you have insider questions that you want to bring up, just unmute yourself and let's make this more of a discussion and less of like a presentation or a lecture. That would be ideal. So let me go ahead and share my screen here. Okay, and do you guys currently see my screen with the presentation on it?
Yes.
Yes.
Okay, great. So just a little background information on myself. I'm the founder of Excel AI. We're a 501c3 nonprofit organization with the aim to lower the barriers to entry in engineering artificial intelligence. Part of how we do that is through study sessions, research discussions, workshops, and training sessions, both on a technical applied AI engineering but then also on shifting your mindset in learning new skills, how to really take on a growth mindset, how to identify your own values for yourself and your organization, and how to reduce bias in artificial intelligence and really consider ethics when doing AI work. So let's get started. So for this research paper specifically, I really wanted to start with going through a lot of what they bring up in the introduction, which is why this is important. Obviously, name embeddings are incredibly valuable for identifying people's ethnicities or genders, specifically to help with trying to figure out different cultural diversity, genetic differences, which is often used for biomedical or sociological research, identifying specific public health disparities based on where someone is located, their nationality. Obviously, for ad targeting in marketing, this is incredibly valuable. And of course, social media analysis, which is one of the examples they actually did in this research paper. And the reason why they wanted to create this specific API is because obviously large data sets don't obviously come with gender or ethnicity already represented within that data set, especially if you're scraping the web, for example. Not everyone likes to give that information publicly, right? So there's not necessarily availability of data, and there are a lot of privacy concerns around that information. So having a tool like this that allows you to identify an individual's gender or ethnicity just based on their name and location is incredibly valuable for this kind of work. And they do talk about some previous research studies that have attempted to do something similar. Those studies they have found are performance constrained. They have small and artificial training sets, and they're based on course taxonomies of ethnicity and nationality. A lot of them focus specifically on using substring distributions. The one that is most has the highest probability in comparison to this specific API is at about a F1 score of like 51%, and their F1 score for this specific API is at about 75%. So one of the things I thought was interesting when looking at some of the previous research, there's another API that's available called NameSoar. I don't know if you guys found that as well when you were looking for this. And NameSoar did a comparison between themselves and NamePrism. NameSoar claims to have a better F1 score for nationality specifically, not for ethnicity, but specifically for nationality. So did either of you guys come across that work as well when you were looking into this?
Yeah, I did. I think there is something on GitHub as well too for it.
Yeah, definitely. So that's something I thought was interesting. I didn't have a chance to really dig into, their claims specifically and why they feel theirs is more robust for nationality, but maybe that's something we can discuss as we go on as well. So performance-wise, they said that they really believe their results will generally agree with the reader's judgment, and they use this figure, of course, to kind of represent that, right? So if we look at the names that they have here and the ethnicity probabilities based on those names with ethnicity and nationality, I just kind of want to pose it to the group first. Do you think that this is actually representative of these individuals' names, or is it not necessarily as intuitive as you would think?
When I looked at it, I noticed that, I think nowadays some of the names can be, may not reflect exactly where you're from.
Yeah.
Or your ethnic background, right? So, I don't know. So
was there a specific name or two that made you feel that way?
No. Sorry about that. Not on this chart in particular.
Okay. And how about you, Moise? What'd you think?
Basically, I was looking at the names of the data mining researchers, and I couldn't remember any that I read their paper previously. So,
yeah, okay, that makes sense. So yeah, I think it is interesting to consider. I personally would find it really hard to try to guess a lot of these ethnicities or nationalities just based on their names. But I think that has to do with the scope of my exposure to other nationalities and ethnicities. So, you know, if anything, I would kind of take it at face value.
Yeah, actually, yeah, I was looking at like Derek Young, for example. It doesn't
Right.
really that could be, you could be white or African, I guess. So it's
Yeah. Yeah,
actually
because if that was a U.S. name, right? Derek Young could be someone of African American descent, right? Or they could be of European descent. So
right.
yeah, definitely. Okay, great. So I thought it was really interesting that they had this major focus on the homophony principle, that people tend to associate with similar people, and they used this kind of saying, birds of a feather flock together. And so that was on the basis that in instant messages, people tend to communicate more frequently with others of similar age, language, and location. And they specifically analyzed over 57 million contact lists from an email company where the account holders were, of course, anonymized. And this led to the word embeddings method as the basis for a comprehensive and effective nationality classifier. Do you guys think that this was kind of a good principle to base this word embeddings or name embeddings idea off of? Would you have thought of this in your own work?
I'm not quite sure myself.
No?
Yeah.
Okay. How about you, Moise?
Yeah, basically the previous work that that has been done on what to vec. So I think this was the right direction to take. If we look at the other path, which was the handcrafted features, so I think that they weren't a very good choice to do further research on.
Right, definitely. Well, they had to base it on something at least.
Yeah.
And yeah, so I think it really depends on where an individual lives, right? Because especially if you're in the US, for example, if you live in a major city, potentially you're going to spend time with people of many different races or nationalities, right? Whereas if you're living in a place that's a little bit more rural, then potentially you would likely only stick to people of similar nationalities as yourself. So that's where I found this to be maybe not as open-minded as it could be. In the most densely populated areas of the US, I feel like this principle wouldn't necessarily apply, but it did seem to work out for their methods. So yeah.
It'd be interesting to actually have a snapshot of the individual's face and use a different type of image recognition algorithm and maybe associate the two. That'd increase your accuracy of nationality potentially.
Yeah, definitely. Do you know if that has ever been done before? If someone has correlated this type of word embedding or natural language processing with image recognition or face recognition before?
Not that I know of. I know in some of these facial recognition algorithms are so amazing nowadays too. I don't know why somebody hasn't really tried to do this.
Yeah, definitely. Okay, let's move on to the next slide. So this is basically what they did when collecting names. They collected 74 million labeled names from 118 different countries, containing over 90% of the world's population, which is great. They really tried to get a comprehensive data set. And then from this, they were able to define 39 leaf nationalities, kind of natural taxonomies. And they went a little bit into detail about how these specific taxonomies are kind of correlated with each other. One of the examples that they used is why they specifically grouped for Hispanic names, why they specifically grouped Spanish and Portuguese and the Philippines, for example. And they said that a lot of people from these specific areas shared very similar names. So it made sense to them to kind of group those together. And then from here, they reduced that nationality taxonomy from those 39 leaf nodes to 6 very specific nodes. that incorporated census-based ground truth parameters into their naive Bayes models. So they looked at census data from 2 different years, and then they basically broke it down into Asian Pacific Islander, white, Black, American Indian, and Alaskan Native as the AIAN, and then of course 2 or more race and Hispanic. Do you guys think that that's actually representative of the world's population when trying to do classification? Would you agree that that's like accurate enough?
Yeah, I think it's a good start. I mean, there's also considerations of folks of mixed race and ethnicities.
Yeah.
How do you determine that? I don't know what the percentage of it is, probably much smaller, but you know, then you have movement from one. You know, nowadays people move from, like, say, you know, Mumbai down to Chennai, for example. You're gonna see a lot of movement between folks, even like in Singapore, for example. So how do you determine ethnicity based on a name? Because, you know, there's a lot of South Indians down in Singapore as well too, for example. So there's going to be little nuances, I guess, that may not be accounted for, but I think it's a good start, perhaps.
Yes. Yeah, definitely a good start. What do you think, Moise?
Well, I also read somewhere that they didn't include the data for 3 countries, which were United States, Canada, and Australia.
Yeah.
because they were predominantly immigrant countries.
That makes a lot of sense.
Yeah. So, and because of that, though, potentially this algorithm wouldn't be as robust on certain groups of people, right? They talked about how specifically for Black people that live in the U.S., it had a lot of trouble classifying their names, especially because during the slave trade, oftentimes people of African descent would take on names of their slave owners. So they would adopt, you know, names that sounded very European or very Spanish, for example, and wouldn't be representative of their nationality. So I really wish that there was a way to kind of have that data represented here to classify those individuals if this data set is going to be used on, you know, U.S. data, right? If this algorithm is going to be used on U.S. data to classify individuals, or if we can do something similar for U.S. individuals.
It'd be interesting to look at the ramifications of what privacy or discrimination when using a data set like this.
Yeah, definitely, I agree. So kind of going into their approach a little bit. So they obviously use this email contact list as their main data source. And the picture obviously is not from the research paper. That's just one I pulled off of Google Images. But first, their kind of order of operations was to assign orders to the contact list. They weight it by recency and frequency of communication. And that's part of the like birds of the feather flock together idea, is the more you talk to someone and the more the most recent people that you would talk to or be in contact with are people that you are similar to. And then they gave those individuals higher weights in likelihood as being similar to you. And then, of course, they equated those large weights to similar nationalities. And then they grouped those top contacts in ways that made it similar to sentences so that it could fall under that word embedding model. Since this isn't really a corpus of text, we don't have like actual sentences, to feed through the algorithm. What do you guys think about their approach to this? Does it make sense to you?
I have no feedback on this one.
No feedback, yeah. How about you, Moise?
Not from my side as well.
No? Okay. I think it makes pretty good sense. I'm not sure how else you could represent a sentence other than potentially keeping these top contacts together in a sorted list. I think their approach is very unique and creative. And I appreciate like the way that they explained it. So yeah, they did go a little bit deeper into how they, for standard word embeddings that normally you would, you know, the order of sentences is kind of informative of kind of the topic of that article. So in this way, the order of context lists is not necessarily useful, right? Because the email of the contact holders are mutually independent. And so it wasn't related to their sentences. So they went into detail about how they stripped the emails, even though they derived a lot of the name information from individuals' emails. They didn't actually use their emails as a basis for like what order they would put these specific sentences in. It had much more to do with the frequency and the recency of the communication. So I thought that was really interesting, personally. And then they went a little bit into their approach of how they decided to actually put together their visualizations. They use pretty standard tools. And their ground truth data, as a comparison, of course, was the US Census data. Specifically for gender, they went back to US data from 1990. And then for ethnicities, they went back to US Census data from 2000. I'm not sure why they chose those specific years. I guess they didn't really go into detail about that. I don't know if you guys have any thoughts on why they chose those years.
Not so much on the years, but I mean, I guess how accurate is the census data in terms of your ethnicity? I mean, are there enough choices on there to give you the determination on that, and how accurate would somebody be willing to specify that? I guess
that's a really good point. I think that's where they specifically got their 6 taxonomies from. The white, black, Asian Pacific Islander, American Indian or Alaskan Native, and then 2 or more race and Hispanic. That's where they decided to derive those groupings from specifically, is based on that 2000 US Census data. But yeah, I mean, like me personally, I'm a mixed person, and I think back in 2000, right, it would have been more normal for me to choose like one specific, race or nationality over another. Whereas like nowadays, I think people have become a lot more granular about like where they're from and wanting to represent specific nationalities. And I'm pretty sure that the U.S. Census data kind of reflects that. I think there are a lot more points available now for you to choose from than there used to be. So it might not be accurate or representative of like individuals today. What do you guys think?
I totally agree with that.
Yeah.
Usually there's a other category, which I usually fall into as well. So.
Yeah, definitely. Okay, great. And I just included this little visualization because I like the idea of them taking a 100-dimensional graph of name embeddings and then kind of squashing it into a 2D model, which we'll see. But yeah. So they went specifically into the name embeddings by gender, and kind of looking at like where each individual name falls, and then also the names that might be a little bit more ambiguous. So this says that this figure 2 illustrates the landscape of first names, obviously from that 1990 census data. They colored the male names orange, the female names pink, and the names with unknown gender gray. In general, names of the same gender form mostly contiguous regions. And here on the right-hand side of figure 2, that little inset shows a region along where male and female borders are really close, right? So Ollie, for example, is one that they bring up, potentially is a nickname for both Oliver and Olivia. So that's why they think it's really accurate that this graph shows it kind of in between, or very close to the line between both male and female. Were there any names just off of here that you were surprised about?
No.
No?
Yeah, I was really amazed to see these two gray regions. In fact, they clustered them correctly if you look closely.
Yeah? So you think...
according to their gender.
So do you think Daryan and Amani are very ambiguous or like unknown?
No, they think they have clustered their gender correctly.
So gray means that it's unlabeled. So they're not sure if it's male or female.
Yeah, but it is actually closer to the male region.
Oh, so Daryan. Okay, yeah. So
which is male.
Which is male. Okay, yeah, that makes sense. I was surprised to see, like, if you look on the graph on the left, how large the gray area actually is. Like, it's almost bigger than the orange and the pink areas.
Right, and you could. I'm guessing you would also see that change over time too. This is what 2000 you said. So, I mean, the more recent you get, the names are going to be. I don't know. They may reflect the cultural norms during that time as well. So. Yeah,
this one was from 1990. Okay. This census data. So yeah, definitely. I would be curious as well if they used an updated data set to do their training, what that would look like. Okay, so let's look at ethnicity then. Next, here they say figure 3 shows a map of last names. They color a name according to the dominant ethnicity classification. This is from the 2000 census data. The 4 major ethnicities are white, which is in pink, black, which is in orange, Hispanic, which is in yellow, Asian Pacific Islander, which is in green, and then anything else is colored gray. So I guess the mixed race or Native American, for example. They pointed out that white, Hispanic, and Asian Pacific Islander are kind of the largest regions. The black is a little bit more dispersed, and likely for that reason, that during the slave trade, African Americans got moved around a lot, but then also had to adopt names of their slave owners. And then also they pointed out specifically that for Asian regions on the map, there's 2 distinct areas, and they go into a little more detail on that in the next slide. So these 2 Asian clusters, the left is Chinese and Vietnamese names, and the right is Indian names. And specifically, they thought it was interesting that the left one consists of the Chinese and Vietnamese. You can see that the ones on the top are more representative of Vietnamese names, and the ones on the bottom are more representative of Chinese names. But I don't know if that also stands for the right-hand side. What do you guys think?
It looks like, for example, Nguyen is in Pham and Tren, and I think the bottom, right in that middle section on the left side, that's more the Vietnamese, where on top, you're going to see more of the Chinese names. And I don't know if the distinction for the Indian names are north versus, south. I don't know. I can't really tell on a lot of that, but.
Yeah. And as you said, there's a lot of movement in these areas as well, like between nationalities. Mm-hmm. So I'm not sure how that could be representative in this data. What do you think, Moise?
Yeah, the figure on the right is actually a correct representation. The above has the Indian names, and below and are somewhat representative names. So I think this is correct. The figure on the right.
Yeah.
Yeah.
Okay. Great. So we're not sure about the left, but maybe on the right. Okay, and then they talked a little bit about the evaluation. You know, really they wanted to make sure that their model was robust. And so they went through some quantitative validations, and they really wanted to explore the sensitivity of the name embeddings under different parameters. The parameters that they checked for included the continuous bag of words and skipgram learning methods. They used joint embeddings for the first and last name, but then they also looked at separate first and last names instead of together. And they also used the k-nearest neighbors algorithm as well to kind of check for those distributions what was close to each area of names. And I just put this picture of the difference between the continuous bag of words and the skipgram learning methods. Are you guys both familiar with these learning methods?
Yes.
I'm not.
You're not? Okay. It's not something that I was super familiar with either. I did pull up the basic definitions that I can share. So the continuous bag of words is a learning method to predict the word by context. It maximizes the probability of the target word by looking at the context. So here on the left-hand side of the image, each of these separate inputs would be basically the context of the sentence. So all the other words that are located around the specific word, you know, you're trying to test for. And then that output would be their relationship to one another. And for the skipgram, how it differs, it's designed to predict context. So if you put in one specific word, then it should predict other words that would be related to that word. So an example, if you were to use the word delightful, it could tell you that there's a huge probability that the context around that word could be something like yesterday was really like blank, right? So like delightful was a really delightful day, right? Or some other relevant context. So yeah, and then I also saw a note that skipgram, with skipgram, the word delightful will not try to compete with the word beautiful, for example, but it's instead delightful and the context pairs will be treated as new observations. So delightful and beautiful would not be necessarily related just because their context is related. Does that make sense?
Yeah, that does.
Yeah, cool. Yeah, I thought it was really interesting too when looking that up. So here, to further their evaluations, they noted that the joint variations generally perform best, but the differences between the variants are relatively small. Overall, the continuous bag of words model outperformed the skipgram model. And of course, they noted that for Black ethnicity names, the probability of classification was really low. And part of the reason for that is because the data set that they used, the probability of having a Black name within the data set was at 0.03%, while, for example, having the probability of a white name come up in the data set was at a 0.74%. So I think it just, you know, had to do with the limited data they had available to test against. Did you guys, you know, find anything else about this table interesting?
I found only the observation that the probability for the continuous bag of words was always greater than the skipgram method.
Yeah. So why do you think that is? I mean, if we look at kind of how they work, right, continuous bag of words versus skipgram, why do you think continuous bag of words gives you a higher probability?
Well, basically, this relates to the training of these. As far as I'm aware of the literature, that continuous bag of words are much more easier to train than skipgram.
Interesting.
Because there we have more context surrounding it, and we have to predict the center word. And in the skipgram, we have to predict like its neighbors, but we have like only one center word. So it makes sense that the continuous bagoverts be much more easier than skipgram.
That makes sense.
Yeah, that does make sense. Okay, cool. Well, let's move on. Okay, so they went a little bit more into their methodology. They used a naive Bayes model. They wanted to find name nationalities depending on both the first and last name. They tried their best to reduce errors when names were mixtures because of things like immigration and internationality marriages. As you pointed out, Moise, you know, they decided to not include specific countries such as the US and the UK, or was it the UK? The US, Australia, and what was the third?
Canada.
Canada, yeah, because of the amount of immigration that takes place. And then they looked at very specific estimate parameters. So the name parts likelihood, features from their training data that were already identified, obviously the name embeddings, but then they also use the substrings and string characters that previous research has also used when doing this work. And they strongly believe that Name Prism obviously uses the estimate parameters with the largest confidence for prediction. Do you guys both understand the way naive Bayes works?
Yes.
Yeah?
Yes.
Cool. I did think it was interesting that they brought up that certain last names, like Li, for example, were popular in both China and the UK. So it would be hard with just the last name to predict where this individual would come from. So I just appreciated that they brought up that example. Can you guys think of any other names that might also fall into that category?
Yeah, I think some of the Chinese names are going to be difficult because you have like Taiwan, you have Singapore. There's a lot of countries that have, so it's hard to predict the ethnicity of that individual, or maybe country, actually. Maybe ethnicity might not be that difficult.
Yeah. What do you think, Moise?
Yeah, the same category, which will also include countries like Korea.
Uh-huh.
Yep. Right.
Yeah, definitely. Okay, so getting a little bit more into the calculations for this, they developed their own algorithm, which they have presented here, where N denotes nationality, V1 represents the last name, VF represents the first name. And they went on to describe their method a little bit more in depth for the likelihood of frequency and for rare names, of course, in the next subsection. But specifically, they just wanted to show that they're using the Bayesian rule under the assumption that the VF and the V1 are conditionally independent given N. And so that was something I wasn't 100% sure about. I know that your first name potentially isn't necessarily going to be dependent on your last name because, you know, of the example that they gave, right? So if you have, you know, someone from the UK, like their first name is going to be way different, even if their last name is Li, than someone from China, right? But I don't know if that's specifically what they were referring to when they say they're conditionally independent. What do you guys think?
Yeah, not sure.
Not sure, yeah.
Well, I think they are both independent, so that's why they wrote the two terms independently.
Oh, I see.
For the first name and the last name.
Okay. Okay. Yeah. I was just curious about that. Okay. And then, so they went into a little bit more detail about the name part likelihood and the four sources that they looked at, specifically their training data, the name embeddings, the prefix and suffix strings, and the name characters. And so here they stated that they estimated the name part likelihood from these 4 sources. And let's see, the context lists that have the name and embeddings, of course. This prefix and suffix, they looked at, I think they only had like 4 or 5 specific characters that were included. The name characters were derived from Arabic, for example, or I think they also pointed out that Korean characters were very unique. And so oftentimes when they weren't sure of a specific classification, it would often be representative of a Korean name. And then they said that they increased the order of vocabulary size based on the decreasing order of estimation confidence. I'm not 100% sure what that means. I don't know if you guys do. No?
No.
Yeah, okay, that's okay. One of the things I thought was interesting that they pointed out here was that names that have similar embeddings does not mean that those names occur in the same frequency or that they had similar popularities. And that's something that they showed as well in figure, here I think figure 3. I mean, it's hard to see probably from this graph. They refer to it specifically that just because a name pointed out to a specific nationality did not necessarily mean that it was also super popular. So 2D production of 5K popular name embeddings, same ethnicity names stand close indicator of similar embeddings, right? Yeah. So that's something I was kind of confused about as well, but I thought was interesting. Oh, I'm going backwards. Okay, let me go forward again. This part I thought was really interesting. Oh, and I did skip over figures 3 through 5 because I had a little trouble understanding specifically what they were doing there. I don't know if you guys had a chance to look into that a little bit more. Here they were saying for figure 3 and 4, and actually I can just share this part of the paper on my screen as well. I don't know if you guys can see that okay.
Yep, we can see that.
Yes.
Cool. So here they were saying specifically, this is where they were involving the K nearest neighbors algorithm. And so, and they were looking specifically at the prefix and the suffix strings. No, that was afterwards. Estimation, simulate by equation 3 and 4. Yeah, I think it would take me doing a little more digging to really understand what these calculations are actually doing. I don't have a background specifically in linear algebra or calculus. I mean, I took both classes, but it's been like 10 years. So
Yep, same here.
yeah. So I'm curious about that. I'll probably spend some more time staring at the formulas, trying to work them out. But I hear that they're not super intuitive, even to math majors. So I'm not super worried about it. I just wasn't sure if you guys had, you know, maybe some more intuition that you could share. But we can go back to the slides. So I did find this interesting, the internet population versus the world population. One of the things that they pointed out specifically for this was that the data sets that they had had an order of magnitude more names from the UK than from South Africa, for example. So they needed to adjust the real population of countries when they were predicting a random name from the world population. And so they basically upweighted names from specific areas that they didn't have a huge representation of, and then downweighted names that they did have a large data set representation of. And I think that that's something that oftentimes people don't realize you have to do when you're considering bias in, you know, data science, and like how to account for not having a data set that is representative of different ethnicities and different groups of people. So I appreciated that they did this. And when they were looking at their social media data specifically, they found that that was much more representative of the world as a whole, rather than the US census data or the email contact list data that they used for training. Do you guys have any thoughts on this?
No, just be interesting to see what when they said social media data, what were they looking at exactly? Again, I apologize, I didn't read the paper.
Yeah, that's okay. They pulled data from Twitter specifically, and they wanted to see basically the nationality and ethnicity and gender of followers of really popular Twitter individuals. So like sports people, and what else did they do? Here, let's see. I don't normally follow popular media, but so they looked at presidential elections. So they looked specifically at the different ethnic groups that followed each president for the presidential election. They also looked at followers of Bollywood stars, for example, and who else? So they just called them Twitter celebrities in general.
Right.
Yeah, so I think it really depends. But yeah, we'll get to that. We'll get to that section in a minute. Okay, so here's part of what they found when they were developing their leaf taxonomies as well, and they were comparing some previous work. So on the left-hand side, the Wikipedia data was the data that's been primarily used for other research papers. And so ethnia is pointed out as the next one with the highest likelihood or probability of being able to identify accurate nationality from names. And of course, PRISM here stands for their name PRISM algorithm. And so they were looking at the email Twitter data that they specifically collected, but then they also used the Wikipedia data that other research papers have utilized in the past. And looking at the comparison, it does have a very high likelihood for specific names, right? So like, you know, Asian names in general, you get a pretty high likelihood, you know, an F1 score, really no matter what algorithm you use, which is interesting. But then like the greater African names, it's much lower, like in some cases even below 50%. And then like Jewish names here, oops, I went back. Jewish names, it's really low. And I'm wondering maybe if there aren't a lot of unique Jewish names, or if they're just not super represented within these data sets. What do you guys think?
Yeah, not too sure.
No. They did say that they to remove noise, they filtered out names that were both where both parts appear only once. So
both parts appear only once.
yeah, so I think like outliers, right? So both the first and last name only appeared once in the entire data set. So there wouldn't be anything else it could group.
Oh, got it. Got it.
Yeah. And so after doing that, 91% of the names remained within the data set. And also they said that, they removed the immigration countries here as well. And didn't include them in this data set. So here they have 68 million pairs of names from their email sources, 6 million pairs from Twitter, totaling 74 million labeled names. One of the things I'm curious about too is if you scrape Twitter, for example, usually you get an individual's username and not really their given name, right?
Right.
So I wonder how that works. Like what they didn't explain what they did in that case.
Yeah, I was thinking the same thing too. How do they make that determination?
Right.
And and if obviously they're not playing either. So
Yeah.
I think that some people choose to make their name public. So, for example, if you use the Twitter REST API, we can have this information like their name, then their username as well. But only if the person makes his name public, real name.
What about picture too? Can you pull that through the API? I'm guessing you could, right?
Yes, I think we can pull the picture. I'm not sure, but there are a lot of information that we can extract, including tweets as well.
Interesting.
Yeah, that's really interesting. Yeah, so definitely if someone wants to do a version of this that includes facial recognition, Twitter would be a great data set for that. Especially if you wanted to increase the representation of, Black names, because the population of Black people on Twitter is really huge. They even have their own Twitter hashtag, right? And so it would be very easy to follow those individuals and kind of identify them based on self-identification in that way. So we could definitely have a more robust data set for those specific groups. I don't know how you can increase the Jewish, kind of the Jewish population in the data set. That would be really hard. And I wonder if that has anything to do with, what happened with the Nazis or not, but.
Maybe you could do bag of words with hashtags associated with the name. I don't know. I'm not sure. Just thinking out loud. Maybe.
Yeah.
I don't know.
And I think it's also, if you look at the frequency of the names based on this table, the largest frequency is of course the Greater European names, probably from colonialism spreading all over the world. But yeah, what other group in the US was really well known for conquering the world? Isn't Chinese, shouldn't Chinese names be represented higher because of the Ming Dynasty? Am I confusing that with another group?
Not sure.
Not sure.
Yeah.
Okay.
Well, American Indian names would have been interesting to see. I guess it's a smaller subset of the population is so small, I guess, compared to. Oh, if they excluded America, then obviously they would pull it out. So.
Yeah, definitely.
Yeah.
Definitely. Okay, great. Let's see. So, here, on this specific slide, they created a continent map that they divided into 4 major parts based on how close they were culturally and geographically related. What they found interesting here was that some names appear to be closely related, even though they're from countries that are kind of far away from each other or on different sides of the continent. So here they said one interesting case is that Angola is connected with Mozambique, even though one is on the west coast of the continent while the other is on the east coast. The reason is that both countries were once colonized by Portuguese, thus many internet users, so this was based on the Twitter data, have Portuguese names.
Interesting.
Yeah. And then they computed the similarities between countries with the following steps. They aggregated name parts of each country so that countries are represented by name part vectors, where each dimension indicates how many name parts occur in the countries. And then they computed the cosine similarity between vectors, so just the name similarities between each country specifically. And that's how they developed this graph here. Did any of this kind of stand out to you guys when looking at it? Do you know anything about like Sudan and Ethiopia? I wouldn't have guessed that like Ethiopia was related to Egypt or Sudan.
Yeah, I don't have any depth of knowledge in that region, unfortunately.
Yeah. How about you, Moise? What do you think?
Well, the African countries are grouped in a similar way as compared to the other Middle East part of the countries, which includes Morocco, Egypt, Algeria.
Yeah. Do you think that is like, would you have inferred that Ethiopia would have been grouped alongside those same areas?
Probably not.
Yeah. Yeah, I find that really interesting. I wonder what happened in history that, you know, like who traveled from where to kind of get to that area.
Yeah.
Yeah. Okay, cool. So these graphs are kind of representative of the Twitter data, specifically when they were following up their testing, basically, of their algorithm. And this is when they pulled in all of the Twitter data. And some of their main observations, which I think are pretty intuitive, for ethnicity, for the 2016 US presidential election, obviously they found that you know, people that were considered white or of European descent seem to have a higher probability of following Trump, and other ethnic groups or nationalities had a higher probability of following Obama or Hillary Clinton, which, yeah, I think is very intuitive, but it's cool that you could see that represented based on this algorithm. And when they broke down the followers of major sports celebrities, they found that cricket and Bollywood stars followers were overwhelmingly Indian, and of course Hispanics disproportionately favored soccer and boxing, which, yeah, if you know anything about those groups, that would seem pretty intuitive as well. One of the kind of outliers that they were surprised to see was that an Indonesian politician named Jeffrey Giovanni was most heavily followed by, I think, Russian individuals.
Were those bots?
Yeah,
Yes, Russians.
I think so. Do people pay for Twitter followers? Is that a common?
I think there was like an investigation nowadays by the FCC to look. They're looking into that.
Really?
Yeah.
Like, what could someone gain from having many Twitter followers? I mean, other than like celebrity status or popularity, right? Like,
so you may have other folks who will. I guess it could impact other people's perspective on something. If there's more Twitter followers and you make a statement, then perhaps you know, the perception is it holds more weight, and you may be able to influence that person perhaps. But also, from my past experience, we've been approached by folks for Facebook likes and stuff like that, which will also impact your ability to sell products too. So
that's very true. Okay, good to know. Do you guys think any of these other findings are really interesting based on the algorithms when they tested their model? How about the fact that people that followed business news were more likely Asian Pacific Islander, and they found a way less likely probability that Asian people would follow entertainment news. Do you guys think that's accurate?
It's interesting.
Yeah.
Well, I think personally, I think it's accurate, but from my experience, but it's interesting.
Yeah, definitely. Yeah, well, that basically sums up the paper. The things I'm really curious about, if this is actually the best algorithm for identifying ethnicity and nationality. Obviously, NameSort claims that their algorithm is better at nationality specifically, and we can pull up their, they have a blog post about it, if you guys are curious about this at all. Here. So I think for ethnicity, they don't claim to be more accurate, but for nationality specifically, so origin versus nationality here. So here they state that they both are somewhat related to geographic countries of origin, of personal names. Okay, and they both do consider the US and Australia to be melting pots, so they kind of left that out of their taxonomy. NameSort does use a smaller data set.
Do you know if there's a database of faces associated with countries or ethnicity?
Not that I've been able to find, and actually, I think that was a point of contention recently in the news. There's one researcher, her name is Joy Buluwami, who specifically, when using a facial recognition algorithm, had a really hard time because it wouldn't recognize her face because she's a Black woman. And so she set out to build a larger data set of, of Black faces to kind of make, that more robust and kind of provide the ability for these facial recognition algorithms to more accurately predict or to recognize an individual, from that group or from that area. So I don't think there is one specific source. I know that ImageNet is trained on lots of different data, right, from the internet, but I don't know what specific data set from ImageNet is going to be most accurate. Because didn't Google get in trouble for that too, like a couple years ago, when their facial recognition algorithm was identifying Black people as gorillas, right? So I would assume that they would, after that news headline came out, I would assume that they probably tried to collect more data to make their models more robust, but they've never publicized that, right? Like their findings or their work in doing that.
Right. I don't think they have, actually.
Yeah. So I really wish there was a better place, and maybe one of us should create a Kaggle competition to get people to do this, because obviously it's needed.
Yeah, I agree.
Yeah.
Well, I would think that that the researcher you just mentioned it would be interesting to actually couple some of this information, if she had names as well, to the facial recognition. I mean, maybe that's something she could pull in. I mean, if she had names. So.
So here, I can include her information as well if you guys are curious. She has created a project specifically. She is out of the MIT Media Lab, and she also has a really great TED Talk that she gave specifically on this topic, where the facial recognition algorithm could not recognize her face. Let's see. I can share this with you guys if you're curious. Her website is www.poetofcode.com, and the research she's doing, she's called it the Algorithmic Justice League, and I can post this in the chat too, so if you guys want more information about it. Let's see. My last slide on here is just some interesting other resources that I figured I would share. That's just the publication. But then more information about these global vectors of word representations. If you're not familiar with the GLOVE algorithm, it's supposed to be the most accurate at this point. And this Medium article I thought was pretty cool. They go into specific detail about how name embeddings work, but in kind of a fun example. This give your kids futuristic names with a neural network. None of the names I would choose personally, but I thought it was interesting nonetheless. This site is the Algorithmic Justice League of Joys, and she includes a link to her TED Talk here.
That's interesting, yeah.
Yeah. But I will share that with you guys as well. Yeah, and I really do wish someone would specifically focus, especially a larger organization, right? Like, like a Google or a Facebook, because they have access to much larger data sets, and, and they have so many researchers working. Page unresponsive. They have so many researchers working within their organizations that could focus on something like this, mitigating bias in AI and machine learning algorithms.
My wife is a chief of staff over at Trust and Safety at Google, so I could probably see if she's. I know she's going to be doing something around this here soon. So.
Well, please share this with her.
I will actually.
Yeah, I would love to hear. If she does have information about that, I think it would be valuable if they are doing anything. Part of the reason why I decided to look into this research paper, just so you guys know, it's a little bit selfish. I'm working on a project right now with a collaborator out of Santa Clara University. She's a law professor, and we're specifically trying to map the pipeline of individuals going through traditional learning trajectories, like universities, going through grad school, but then also alternative education programs. And we're trying to see the differences between men and women and other ethnicities, and trying to identify like what's actually happening in the tech industry right now. Obviously, large tech companies have been volunteering some of their demographic information, on who they have employed within their organizations, but it's not 100% clear or transparent, the data that they're providing, and there's no way to verify accuracy. So we're actually going to be applying this name prism algorithm to many different data sources that we've been gathering. But that was part of the goal for today, is just to better understand this algorithm specifically and see if there's anything better in the market. And I do like that idea of kind of coupling this name embedding algorithm with a facial recognition algorithm. So depending on resources, we might try to do something like that.
Sure.
Yeah. But yeah, so that's all that I had for today. Is there anything else in relation to this research paper or anything else you've seen similar to it that you guys want to talk about?
Not in particular, but I was interested in like I said, if there was an algorithm, or not the algorithm, but a model that you can actually kind of just build and test and play around with. I'd love to get it on our platform.
Yeah, what platform is that specifically?
It's onepanel.io. Yeah, so matter of fact, instead of actually donating, we'd love to be able to help you guys out. You can set up. We have optimized GPUs on the back end.
Interesting.
We could, what you could do is you could set up an account for Excel.ai. You could use it and have your own unlimited GPU access on our platform, where you can spin and test up and actually collaborate and share, models that you build on the platform. So.
Yeah, I would love that. Okay, so I just want to make sure I'm on the right site. So this is One Panel here?
Yeah, we're still early stage startup. So,
yeah.
But yeah, if you click on dashboard, and then go to public.
Okay.
We're still in beta, and you can see these are some of the projects I've been building out in there. And we have about 100 some users. So right now, if you sign an account, just let me know, and what I'll do is I'll lock it in for you guys.
Great.
And you'll have access to free GPUs. There's collaboration. So if you click on, maybe scroll down a little bit.
Yeah.
Let's see, maybe keep going.
It looks like that's the end of my scrolling ability.
No, I mean, you go to the page 2.
I see. Okay.
You can go to the nuclei challenge. Actually, go to the let's see. Yeah, go to the nuclei challenge. That's fine.
Okay, let's see.
And so what you can do is, if you were to create a project, for example, there's notebooks in there. Once you log in and sign up, you'll actually be able to create and spin up machines or notebooks like Jupyter Lab.
Right.
You could, and then you could create multiple parallel jobs on GPUs on there. So yeah, if that's something that we could offer you guys to free support. So and GPU access. So which is
cool. Definitely. So do you guys just use like AWS in the back end, or what do you guys doing? Yeah.
So right now we're all AWS, but we're gonna be able to spread across any cloud environment, and also bare metal as well too. So say if you had your own GPUs at home, you could install our platform on there and do like a hybrid configuration. So if you run out of GPU, you can actually go and send it to the cheapest available cloud. And you can actually create data sets. You'll be able to mount them. You can fork projects in there, and you can share and collaborate too. So yeah. So say you built out a project, you can have, you can actually provide access to anybody in a meetup, in one of the meetups, so they can actually see and actually play around with the algorithm and actually spin it up, etc. So.
Very nice. Okay, yeah, I will sign up for this, and I'll send you a message. You did sign up on the meetup, yeah?
I did, yeah.
I have your information. Okay, and actually, if you can send me your email directly, we can talk more about this, and I can list you guys as a sponsor on our website. Yeah, and I love that. I love to help out other startups, and thank you for helping us out as a nonprofit. I appreciate that. So if we can help you guys get the word out too, we would love to do that.
And I think in this particular algorithm too, coupled with an image, some sort of image classifier as well, would be interesting. You could build it out on our system and put it out there in public. Well, you'll be able to spin up APIs too eventually. So
right.
Which is really interesting. That's why I kind of keyed in on this project anyways to begin with. So.
Okay. Well, great. Thank you very much for that. Okay, how about you, Moise? Did you want to share anything else before we call it a day?
No, I to specifically talk about the image recognition algorithms. So there are basically two that I'm aware of. One is DeepFace, and the other is ImageNet.
I don't think I've heard of DeepFace. Let's pull that up really quick.
They basically use image embeddings for image recognition.
I see. So this is Facebook's then, yeah? DeepFace, Facebook research. Closing the gap to human level performance in face verification. So I wonder what their data set, 97% on the labeled faces. Wow, data set. For current state of the art, 27% on human level performance. That's awesome. I will definitely look into that more. And maybe if you guys are interested, we can cover their paper as another research discussion coming up soon, so that potentially we could couple these two algorithms and propose some new research to be done. Yeah?
Yeah, that's cool.
Okay, great.
Wow.
Awesome. So just so you guys know, we do have some other specific events coming up soon. I think the next research discussion like this has already been proposed. The person that's leading it is more interested in user experience and ethics. So she's going to be covering a paper called The Value Learning Problem, and that's going to be Olivia Walter, who is part of our organization. We also have, recently we had a mindset training for AI enthusiasts that took place in Oakland, and that went really well. We'll be having another one of those specifically coming up early March. So those are really targeted at new people who are breaking into artificial intelligence and looking to kind of shift careers. So we really help them understand how to take on a growth mindset, how to learn, really identify their own learning styles, how to identify their values, and how to start thinking about bias within artificial intelligence engineering, and to be more mindful in their work. And we're also going to have some more applied AI engineering workshops coming up. Specifically, we'll be hosting another image recognition and TensorFlow workshop on February 28th. I haven't posted the event yet, but it will be posted within the next couple of days. So if you're interested in joining us for that, we would love to have you. We're going to have another gentleman who will be covering an intro to machine learning with applied examples, likely in scikit-learn, coming up as well in the beginning of March. So keep an eye out for that. And if there's another type of study session or workshop or anything that you guys are interested in hosting, I would love to have you guys join us as hosts or presenters, or just to share your work. And I want to thank you again for joining us this evening for this research discussion.
Awesome. Thank you. Thank you for taking the time to put this together.
Yeah, no problem. Okay, guys. Well, I will talk to you soon then.
Awesome. Take care.
Okay. Bye-bye.
Bye-bye.
You too. Bye.
Bye.